Okay. Now let us take another example on mean value theorems. Okay. Now this is verify Rolle's theorem for this function. For fx is equal to x into x plus 3 whole to the power x into x plus 3 into e to the power minus x by 2 on minus 3 0. Okay. Now let us check the applicability of Rolle's theorem and then we will find C. That is the meaning of verifying Rolle's theorem. Now fx is a multiplication of two functions. One is what? Polynomial, another is exponential. We know an exponential function is a continuous function and polynomial function is also a continuous function. Now clearly fx is a product of a polynomial and an exponential function. Hence, is continuous and differentiable everywhere. Over. Now come to the conditions first. Hence, first condition, f is continuous on closed interval minus 3 0. It may be continuous differentiable everywhere. You will have to write the conditions. Second, f is differentiable on open interval minus 3 0. Again, our third condition, what is f of minus 3? Obviously it is 0. That is same as f of 0. Thus, the conditions of Rolle's theorem are satisfied. Hence, Rolle's theorem is applicable. Now, what is my fx? It is x square plus 3x whole into e to the power minus x by 2. What is my f dash x? It is first into derivative of second, x square plus 3x into e to the power something, e to the power that thing, into derivative of that thing minus half, plus e to the power minus x by 2 second, derivative first, x square ka 2x and 3x ka 3. Take e to the power minus x by 2 common. What you are getting? क्या मिल रहा है? माइनस एक्स स्क्वायर माइनस 3x plus 4x plus 6. Now take a minus common also. So minus e to the power minus x by 2 whole into x square plus x plus 6. Okay? Plus 6 no minus 6. Is it? Minus x minus 6. Now f dash x equal to 0 gives me x square minus x minus 6 is 0. How to factorize this? How to factorize? Yes, I shall give you a very simple technique. What is the factor of this? 1 ka? 1. Write this twice. Okay. And what are the factors of 6? 2 and 3. Okay. Now, my multiplication of two numbers is minus 6 and addition is minus 1. Mark. Yes, I take plus 2 and minus 3. Getting the idea? ये idea लगाना, it is easy. So, it is x square minus 3x plus 2x minus 6 is 0. So, x into x minus 3 plus 2 into x minus 3 is 0. So, this gives me x minus 3 into x plus 2 is 0. I got x equal to what? 3 and minus 2. But out of all these 3 and minus 2, that what belongs to a b or which lies between a and b, that is my c. So out of all these, yes, but minus 2 belongs to minus 3 and 0. My a was minus 3 and b was 0. Okay, जो ये interval में आएगा, that what is between a and b, that is my c. Therefore c equal to minus 2, that belongs to minus 3 0, such that f dash c is 0. The Rolle's theorem is verified. Okay, getting the idea? Now let us take another question. This is question number 3 of your book. Very interesting question. See, open your book and look at that question. What is that? F is a function from closed interval minus 5 to r is a differentiable function. And f dash x never equal to 0, does not vanish. To prove f of 5 is never equal to, f of minus 5 is not equal to f of 5. Okay, we will have to prove this. We will solve this question by method of contradiction, if possible. Let f of minus 5 is equal to f of 5. Now, f is differentiable. That implies f is continuous. Therefore, f is continuous on closed interval minus 5 because f is differentiable. F is differentiable on open interval minus 5 because given it is. And we have taken f of minus 5 equal to f of 5. That implies conditions of Rolle's theorem are satisfied. This gives me, we find a c belongs to open interval minus 5 such that f dash c must be equal to 0, which contradicts the fact that f dash x never equal to 0. That is a contradiction. Therefore, our assumption is wrong. So what is right? That implies f of minus 5 never equal to f of 5. Very simple. Getting the idea? Now we shall begin mean value theorem. Invented by the great mathematician Lagrange. Okay, sometimes we call this Lagrange mean value theorem. Okay, कभी कभी इसको बोलते हैं Lagrange mean value theorem. Okay. Getting the idea? Now let us write the statement. Let f is a function, it is a real valued function. Defined on closed interval AB such that it satisfies the following condition. F is continuous on closed interval AB. And the second condition is F is differentiable on open interval AB. Okay. Here there are two conditions. Third condition is not there. Then there exists a C belongs to open interval AB that lies between A and B such that f dash C is FB minus FA by B minus A. Okay, f dash C is FB minus FA by B minus A. Let us analyze this. F is continuous in this closed interval means if I draw the graph of fx, there is no break between A and B. F is differentiable on AB, open interval AB, means at every point we find a tangent, okay, between A and B. Understood? F dash C means slope of the tangent. FB, y coordinate at B, minus FA, y coordinate at A, मतलब y2 minus y1 by B, x coordinate, A, y coordinate, y2 minus y1 by x2 minus x1. What is that? It is slope of the line joining two points. That is, slope of the tangent f dash C at some point is equal to slope of the chord joining 2 points. Means I can find a tangent which is parallel to the chord. This is slope of the chord. Same as slope of the tangent means two lines. They have same slope. Means they are what? Parallel to each other. Okay. Now let us discuss a little bit on this. Now here let this is the graph of a function. Okay. If p equal to f, it is not there. So let me take 2 points on the curve. This is A and here is B. Over. Let the x coordinate is A and B ka x coordinate B. So obviously the y coordinate is f of A because the curve is y equal to fx. So x coordinate is A. Here y coordinate is f of A. And for this x coordinate is B and y coordinate f of B. F of B. Now there is a continuous graph. Getting the idea? So if there is a continuous graph, then if I join AB, what is slope of AB? FB minus FA by B minus A. And can I get a point on this AB, mark here, where the tangent is parallel to this? Yes. So that is the mean value theorem. This point is C. Okay. And the coordinate is C and FC. Okay. where f dash c, slope of the tangent, is same as slope of the chord AB. This is the basic idea of what? Mean value theorem. Now, this is its geometrical interpretation. That is, if there is a continuous curve between 2 points and at every point I find a tangent, then slope of the chord is same as slope of the tangent at some point between A and B. That is, we can draw a tangent which is parallel to the chord. Okay? Now, this is the basics of mean value theorem. You will have to remember what? The statements of both the theorems. Okay? Now, let us take one example on mean value theorem. Okay? Let us take your book's question. I think that will be better. Now, this is question number 4. Verify mean value theorem. For fx is x cube minus 5x square minus 3x. Okay. X square minus 4x minus 3x. This is number 5. Okay. 3x. In the interval AB, where A is 1 and B is 3. And also find C belongs to open interval 1, 3 such that f dash c equal to 0. ये क्वेश्चन करते हैं. Now mark here. We will verify a mean value theorem for the function fx is x cube minus 5x square minus 3x. Now, clearly it is a polynomial. It is a polynomial. Hence, is continuous and differentiable everywhere. ये हर जगह में continuous and differentiable है. Therefore, first, f is continuous on AB means 1, 3. And f is differentiable on open interval 1, 3. Now, what is f dash x? 3x square minus 10x minus 3. Okay. What is fb? F of 3. What I am getting? 27 minus 5 into 9 minus 3 into 3. Okay. What it is? 36. 36. It is 27 minus 6 into 9. 54. So it is minus 27. And what is f of a? F of 1. ये क्या है? 1 minus 5 minus 3. It is minus 7. Now, what is fb? Minus fa by b minus a. क्या है? Minus 27 plus 7 by 3 minus 1. It is minus 20 by 2. It is minus 10. Okay. Now, f dash x equal to minus 10 gives me 3x square minus 10x minus 3 equal to minus 10. This gives me 3x square minus 10x plus 7 equal to 0. So this gives me 3x square minus 7x minus 3x plus 7 equal to 0. This gives me, okay, x common 3x minus 7 minus 1 common 3x minus 7 equal to 0. So what I got? I got x minus 1 into 3x minus 7 is 0. So I got x minus 7 into 3x minus x minus 1, 3x minus 7 equal to 0. Now, so out of x is 1 and x is 7 by 3. Out of these, only this 7 by 3 belongs to 1 and 3. Therefore, C equal to 7 by 3. Next, the rider question is, we will find a C such that f dash C equal to 0. What is f dash x? 3x square minus 10x minus 3. 3x square minus 10x minus 3 is 0. So x is 10 plus minus root over b square 100 minus 4ac, it is plus 36 by 2a 6. 10 plus minus root over 136 by 6. Okay. None of the values lies between 1 and 3. Therefore there is no C belongs to 1, 3 such that f dash C equal to 0. So you shall solve as many questions as you can.